My name is Karl Lundahl. I'm employed as VP Product Management at Smoltek.
Hi, Karl.
Smoltek's CNF MIM concept is developed for both integrated and discrete capacitors. But which application will reach the market first?
Well, we have a lot of traction in both fields actually, but at the moment there is an enormous interest for the discrete implementation of the CNF MIM technology. So we believe that the first products that will be launched on the market will be discrete capacitors.
And what would you say are the main advantages of CNF MIM compared to existing capacitor concepts?
Well, I would say it's really a combination of electrical and physical aspects of the technology. So on the electrical side, the CNF MIM technology offers a very high capacitance density in combination with very low losses in terms of inductance and resistance. And on the physical side, we're able to provide that attractive electrical performance in a very small form factor. And especially, we can make the capacitors very, very thin. So the combination of these features makes the CNF MIM technology suitable for high-frequency applications, and in particular where a lot of capacitance is needed in direct proximity to an integrated circuit, such as, for instance, a processor.
Could you give an example of an existing application where Smoltek's CNF MIM discrete capacitors are especially suited?
Well, one example of an application where the CNF technology has gained a lot of interest recently is for the use in mobile phone application processors. So let me show you one of these more advanced processors that are used today in the marketplace. So this is an Apple A13 Bionic application processor, which is currently used inside, for instance, the Apple 11 Pro and other devices produced by Apple. So if you turn it around, this application processors, on the back side you will find around 1,300 solder ball interconnects which interconnect this application processor package to the motherboard of the phone. But in between those balls you will also find some square or rectangle shiny quadrants here, and those are advanced silicon capacitors which are positioned in between those interconnect structures. And the reason that those capacitors are here and not outside the package is that they need to be very, very close to the processor die, which is inside, just underneath this surface here. Because if you put them outside the package, the leads, the electrical connection, will induce too high losses at these very, very high operating frequencies. So it's very good to have this immense amount of capacitance very close to the processing unit inside this package. But it comes at a cost, because these capacitors eats up real estate area, which would otherwise be available for those interconnect structures. So one set of criteria is that we need a lot of capacitance very, very close to the integrated circuit processing unit itself, but we also need a lot of interconnects. So these are kind of contradictory constraints if you look at this geometrical layout of this package. So one obvious way how to increase the amount of interconnects is to make them smaller, right, on the same area. But the thing here is that if you would like to make those smaller, which is technically possible, by the way, in the infrastructure we have today in the semiconductor industry, the capacitors that's available today are too thick. So if you want to maximize the number of IOs, you need thinner capacitors, and thereby you solve this equation. And this is where we think we have an advantage as Smoltek with our CNF MIM technology, because that provides the manufacturers the ability to make 5 to 10 times thinner capacitor than what's available in the industry today. So we think here is an example of an application where the CNF MIM technology could bring significant value in the future.
So Smoltek has proven the concept in the lab, but how do you take it from there to high volume production?
Well, for the discrete CNF MIM capacitors, we are currently working with two types, you can say, of prospect licensees. On the one hand side, you have typically very large companies, you can call them conglomerates, which have several different business units inside the same company. And these types of companies typically have semiconductor know-how, experience and infrastructure already established within their own factories. So these kind of companies typically would like to scale up and ramp up the CNF MIM technology in-house using their own factories for the production. Then we have another set of prospect licensees that may not be necessarily have the semiconductor knowledge and experience and production infrastructure in their own factories, in their own facilities. They typically would like to outsource the production using existing foundries that's available in the semiconductor production ecosystem. And at Smoltek at the moment, we have tracks or ambitions to support both these routes for industrialization. And we have several projects ongoing at the moment where we are aiming towards scaling up the technology.
So finally, what would you say are the biggest challenges in being able to manufacture CNF MIM in high volume production?
Well, I think we have now proven that we have performance for the discrete capacitors that is at par or even better than what's available in the industry today. So the main challenge now is when we are entering a new and very interesting phase is to how to scale this high-performing technology cost effectively and in a supply chain that is capable of delivering extremely high volumes. We are not talking about hundreds of millions here. We need to scale it in a supply chain that is capable of delivering several billion units a year, perhaps even more than 10 or 20 billion units a year. So I think that the main challenge here is twofold. So we need to adapt our 15 years of experience in carbon nanotechnology to an existing tool base that is available in the semiconductor infrastructure. So that may have implications in both how you make the capacitor itself in terms of the processing, but also how you design the final product. The good thing here is that when we now are embarking on this journey, our IP portfolio in terms of patent is very broad. So many of the changes that we now see that we need to do in order to scale the technology is covered by our patents. So that's a very good thing. So also in the ongoing process of industrializing the CNF MIM technology, we need to address other important aspects apart from the performance itself. And any semiconductor device or electronic device, we need to consider the reliability and the robustness of the product. We need to consider the manufacturability and the cost and the production yield. It's very important aspects. And these aspects are currently being addressed in several projects that we are currently running now during the fall.
Thank you very much, Karl.
Thank you very much for having me.